Good morning, students. Today I will discuss about the properties of alkene. So we'll go into the class. Properties of alkane. So coming to the properties of alkane. So basically in the properties, we can discuss in two ways. One is in physical properties and second one chemical properties. In two ways we can discuss. Coming to the physical, in physical properties, only one point we need to discuss, that is boiling point. Okay, boiling point only is very important. Boiling point. Coming to the chemical properties, so a lot of things we need to discuss. So first one, that is about halogenation. Okay, halogenation, and second one is aromatization, and third one, reaction with steam. And fourth one, pyrolysis. So these are the chemical properties for the alkane. And coming to the physical, only boiling point is important as per the examination point. So we'll discuss one by one. So we'll start with the physical point. Okay. So physical properties. So in physical properties, we'll discuss about boiling point. So if you see any compound, okay, for example, we'll take alkane, like this is methane, and this is ethane. And if you take another compound like propane, so if you see the all the compounds, molecular weight will increase gradually, right? So when molecular weight is increases, boiling point also will increase. Okay, this is common. So this is directly proportional to the boiling point. If molecular weight is also increases, then boiling point also will increase. But in few scenarios, this is the first scenario. In the second scenario, uh, if you see the straight chain compounds and the branched chain, straight chain compounds have the compounds have more boiling point than branched chain compounds. I will explain. For example, let's take one example. If you take uh, pentane, if you see here, this is the pentane 1, 2, 3, 4, and 5. This is also 1, 2, 3, 4, 5. This is also 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So both are pentane, but this is normal pentane and this is the branched one. Molecular weight is same in the two compounds. Here in the straight chain compounds, if you see here, here there is a formation of intermolecular force of attraction. So if you see here, there is a force of attraction. There is a interaction between the two molecules. Okay, there is a interaction between the two molecules due to this. Okay, for this break this bond, we need to supply the more amount of heat energy. Due to this, boiling point also will increase. But if you see the branch chain compounds, the interaction percentage is very less. The area of percentage, for example, if you see here, the area of interaction is very less. If you see in the straight chain compounds, the area of percentage is very high. So due to this, straight chain compounds have a more boiling point than packed chain compounds. This is about boiling point. So we in this boiling point, whatever in the physical properties in the boiling point section. So we have discussed about two main things. One is about normal compounds. Another one about straight chain compounds have the more boiling point than branched chain compounds. Okay. So we'll discuss about the chemical properties. Chemical properties. Okay. First one, halogenation. First preparative method. We'll discuss one by one. So what is the first preparative method is halogenation. In halogenation, let's take the one alkane. On reacting with the chlorine in presence of UV light. So what will happen? So basically one chlorine will react with that. So CH3Cl it will form and it will come out as a HCl. Okay. So further, so sunlight is means unstoppable, right? For example, if you are doing the same reaction in the laboratory, that is controlled reaction. But if you are doing that reaction in the sunlight means that is uncontrolled reaction. So again, one more chlorine will react. So CH2 and Cl2 will form. It will become HCl. And another Cl2 will react. CaCl3 and plus HCl. And then Cl2 will react CCl4 plus HCl. So then further, in case if Cl2 react, there is no reaction. Why no reaction? Why it happened, right? There is no further hydrogens are there for react with the chlorine. So that's why the reaction is stopped and we'll get no reaction. There is no product we'll get it. Okay. So this is halogenation. So in the first step, if you see here, in the first step, initially when it's react with the chlorine, you will get the methyl chloride. Okay. So after reacting with the chlorine, you will get the methylene chloride. After reacting with the methylene chloride again with the chlorine, you will get the chloroform. Again reacting with the chlorine, you will get the carbon tetrachloride. So this is about halogenation in the alkane. So we'll discuss about one more reaction, that is about mm, aromatization. Okay. So we'll discuss aromatization. If you see here, aromatization. In aromatization, let's take any compound, like if you take the, for example, if you take the butane, it will form. So in aromatization, we are using agent is Cr2O3 by Al2O3. This is the aromatization reagent. So during this aromatization, by using butane, we'll get the butane, means cyclobutane. In case if you are using pentane, right, you will get the product like this. This in aromatization, the first one. In the aromatization in the second example, you will get the cyclopentane. Okay. Cr2O3 by Al2O3. Here also same thing. Cr2O3 by Al2O3. So this is the way aromatization will happen. From alkane, we will get the cyclic related compounds by using aromatization. Okay. And coming to the some more preparative methods. Reaction with steam. Reaction with steam. Let's take any alkane, CH4, on reacting with water. Steam in the sense, basically water in the liquid form. That water in the vaporization state, when we are in the vaporization state, when we are reacting with alkane, that is called reaction with the steam. Steam in the sense, the liquid which is in the gaseous state. So on reacting with water in terms of nickel, we'll get carbon monoxide with 3 moles of hydrogen. We'll get it. And pyrolysis. Reaction with pyrolysis. Let's take any one alkane. For example, CH3, CH2, and CH3. Pyrolysis in the sense like cracking or heating. Okay. So in case if you heat this in which an very high temperature, we need to apply the very high temperature. Cracking in the sense we need to apply the heat very high temperature. So what will happen? It will break. Okay. So I will go CH2. Will get the products. Okay. This is about properties of the alkane. Thanks for watching this video. If you like this video, please subscribe my channel. Thank you. Thanks, students.